Hey folks, welcome to the very first video of our series. This is just a quick summary, as you can see from the image on the screen, just to give you an idea of how in depth we will be diving into the course. We will cover some crucial steps that will not only deepen your understanding but also enrich your knowledge from the surface modeling phase all the way to the real-time rendering in Marmoset toolbag. Now let's take a quick look at the first step and what we'll be tackling. The first step is all about volume modeling, followed by surface modeling. Essentially, you want to block everything out to give your weapon the right volume and shape. Details can be added later. But if you're like me and can't wait to dive into the details, go for it. There's nothing wrong with that. However, good practice suggests that starting with a solid blockout is the way to go. Alright, let's quickly see the second step, working in real scale in Blender. Okay, basically, you want to make sure that your 3D model is scaled relatively to the 3D world or to the real world. Okay, so let's import the weapon. As you can see, it's kind of huge. First thing first, you want to rotate it by 90 degrees and freeze the rotation. Okay, then add a simple cube. A simple cube by default is 2 meters by 2 meters in Blender. You want to click and then left click and set the cube to 1 meter. Okay, then select everything, deselect the cube and scale the weapon down till it matches the cube, just like that. And so this way you're gonna make sure that the weapon is as big as the cube. I mean 1 meter, 100 centimeter. It doesn't really matter if it is 90 centimeter, 95 centimeters along the y-axis. Just make sure it is as big as the cube, give or take. Okay, that's it. Don't forget to freeze your transformation by pressing Ctrl A and give to Alt Transform a left click. Okay, third step, retopology using both manual and Z-remesher in ZBrush. That's what you want to go for. Okay, basically what I'm doing here, I'm deleting all the rivets except one. Okay, I'm deleting the screws and the bolts, and I'm gonna keep just one for type because I'm gonna unwrap them and then I'm going to duplicate them. Okay, no need to unwrap all the stuff here. So let's delete everything and just keep one rivet, one screw, one bolt, just like that. Okay, then I'm also keeping the initial connector, this one right here, and the connector in the middle that is supposed to connect the pipe. Okay, I'm gonna keep this one and this one. We can delete this as well. Okay, then join them all with Ctrl J. There we go. So one thing you can do at this stage is export your mesh to ZBrush and try to retopologize it using Z-remesher. It often does very great work, but you need to use the crease function, and this we'll be seeing that later on in the series. And you can retopologize the simplest stuff in Blender by using Retopoflow. So use both Z-remesher and Retopoflow in Blender. What you want to do at this stage is opting for manual triangulation. You don't want to export your 3D model with automatic triangulation. Okay, Okay, number 4, check your silhouette, use shrink wrap if necessary. Let's have a look at how to do that. As you can see, you need to turn on the high res mesh and the low res one contemporaneously. And when you see this kind of flickering, it means that they are perfectly overlapping. The low res mesh is perfectly wrapping around the high resolution mesh. If they are not, you can use the shrink wrap modifier. Okay, you can select the low res mesh, add the shrink wrap modifier, click on the eyedropper, then select the high poly, and bam, this will wrap perfectly the low res mesh around the high one. Let's go ahead. Number 5, optimization of the meshes and reducing the poly count. Okay, so during this phase, you just have to remove all those edge loops that do not contribute to the overall silhouette of your low res mesh. Okay, do you know those pesky edge loops that do not help maintaining the low res mesh silhouette? Well, you want to remove all of them, collapse them. Just be careful and pay attention to those loops that keep the silhouette of your 3D model. Just do not remove them. If you do that by mistakes, just hit that combination Control Z to undo that. Okay, so you can create the stage quads. You will create quads naturally, but you can create trees and n-gons as well. Okay, as long as they are placed not in curvy surfaces. So steer clear of creating trees and n-gons on curvy areas. Okay, the optimization process is all about reducing the poly count, trim down on poly count. Okay, on the other hand, you don't want to clutter your mesh. Okay, so the trick is remove all the polygons, all the edge loops from flat areas. Just keep them edge free if that is possible, and focus concentrate most of the geometry on curvy areas to retain as much details as possible. The low res mesh must resemble as close as possible to the high resolution one. Okay, that's the trick you want to go for. Okay, let's go ahead and see what number 6 is about: unwrapping, UV mapping, biasing UVs, and packing. So all you need to do at this stage is go to edge mode, select your sharp edges. You can do that by either using a manual approach, or you can go to select up here and then click on select sharp edges. Okay, once you've done that, you can right click and click on mark seam, and that's how you mark down your seams. Then you can press U and choose one of the unwrapping method listed in that menu. Okay, let me give you another example using a more complex mesh. As you can see, I selected all my hard edges automatically by going to select sharp edges, but not all the edges were selected as I would like. Okay, you will always find yourself in a situation where you need to select your hard edges manually, and in just like in this case, you need to split this island here because it's way too long, and this will prevent unwrapping your mesh properly. Okay, now just press U and unwrap it. As you can see, this island here is way too long. In this case, you just want to split it at least in 3 parts, and take a look at that. It speaks for itself. Now all the space All the UV space has been covered. Okay, number 7. This is the dilemma, folks. Choosing whether to use single UV tile or UDIM, single material or multiple materials. Alright, if you take a look at this model by pressing tab, we go to edit mode. You can see that Blender slammed all the UV islands into the 0,1 UV space. So this is a great packing job, guys. But on the other hand, this will lead inevitably to blurry and pixelated texture. Now, there is a simple solution to this problem. We can use multiple materials to distribute the UVs across them. Okay, this is a great way to scale up the islands and increase the texel density. We need to do this because Blender tends to cram everything into a tiny space, and it doesn't realize the consequences of that action. Okay? So it's up to us to guide Blender on what to do. So you might wonder why I'm not using multiple materials. Well, each material adds a draw call to the stack in Unreal Engine 5. What's a draw call, you ask? Think of it as a request sent by the game engine to your GPU. The more draw calls you pile on, the laggier your computer will become. Okay? That's why we want to keep those draw calls to a minimum. Okay, now let's talk about UDIMs. UDIM is the most universally recognized UV mapping method used across the video game industry. So they often utilize a massive number of UDIMs, sometimes up to 500 or even up to 1000 UV tiles, depending on the complexity of the 3D model. In short, I'm going to instruct Blender to use at least 4 UV tiles in our case. So that's more than enough. Okay, so here is where the magic happens. We will spread the UV islands across multiple UV tiles, but we will only use one material for the entire rifle. This approach not only scales up the UVs, gaining us more UV space, but it will also dramatically boost the texel density per centimeter. It literally will skyrocket the texel density per centimeter. The result, crisp, stunning textures with incredible detail. You'll be able to zoom in and see details as if they were under a microscope. Okay, sounds good? Let's go ahead. Number 8. So, mirroring concept. It allows us avoiding overlapping polygons while gaining UV space. Okay? Alright, as you can see, I've trimmed down many parts of my rifle, not because I prefer it this way, but because I'm planning to pack all the UVs into just 4 or 5 UV tiles. After that, I'll mirror those parts and shift the mirrored sections exactly by 1 unit on the y-axis. This way, they will occupy the same UV space but will be offset by 1 unit. This technique allows us to maximize our UV space during the packing phase, and by shifting them over, just like in the video, we can eliminate overlapping UV islands. Isn't that fantastic? So that's the essence of the mirroring concept, folks. Okay, we're almost reached the top. Number 9, smoothing by UV islands. That's a crucial step for baking out. So number 9, this is the crucial step to achieving that dreamy bake you've always envisioned. We're talking about smoothing by UV islands. Essentially, Blender will create the necessary hard edges based on your UV boundaries. It's all about creating smoothing splits with padding, okay? Or hard edges. Remember the golden rule. Whenever you have hard edges, you must have seams on them. This will provide the right information to Substance Painter, allowing it to properly bake your 3D model, okay? Okay, number 10, one of the most crucial steps, folks. This is a real time saver. This step will help you avoid the hassle of exploding your entire meshes, saving you tons of time and effort. As you can see in the video, all you need to do is rename your meshes properly. No need to go through the trouble of exploding all the meshes. Okay, just label them as either low res or high res, keeping the same name but changing the suffix. For example, you could use stock rifle underscore low for the low res mesh and stock rifle underscore high for the high res one. This way, Substance Painter will easily recognize which is which, preventing texture bleeding across different parts of the shotgun. Sounds good? Alright. Okay, the final step, number 11, is texturing in Substance Painter. This is the most intricate part, folks, and we're gonna dive deeper into it throughout the course, folks. Okay? Alright, if you navigated the texturing process and exported your textures for Marmoset Toolbag, it's time to dive into real-time rendering. What can I say? Happy ray tracing. Marmoset truly shines when it comes to ray tracing, folks. By tweaking over 100 options, we will create a vibrant and realistic silenced sniper rifle that showcases the magic of ray tracing. We will be seeing what this magic software can really do along the course. Oh, just a friendly reminder, this course isn't designed for beginners, and many of the recorded videos won't have narration.